about the pixels, I already explained too much. And once again, I would like to highlight a little bit that pixel is what? It's kind of light intensity. It's light intensity. Before this, I was talking about some kind of thing that pixels, okay, can be considered CCD, charge coupled device, where each cell is storing the light intensity. And this light intensity in restoration phase comes in form of some values, numeric values. And the range of these numeric values can be encompassed in the 256 value. Okay, range started from 0 to 255. So total 256 values, or you can say 256 shades. Here we are considering some kind of a color image. Of course, I'll explain this color image a little bit at the later coming slides. But important thing is this CCD is transform the light intensity in form of some numeric value according to the intensity. If intensity is too high, then numeric value will high, near to 255. If intensity is low, numeric value will become 0. For example, here the intensity, reflected from some object, because a black object absorbed the maximum amount of light. Then, camera captures the intensity. Light reflected from this part to the camera aperture or to the CCD, charge coupled device, inside of a camera is very much low, because maximum light will be absorbed by this black. But once the light reflected from this white, maximum light will be reflected and reach to the CCD, charge coupled device. So pixel is what? Intensity of light. And all the variations of, so here again, if we say that the sun, we are talking about the pattern of the CCD is what? CCD partition like this, in square form. And you can notice here the scale, all the scales. But scales are, if we are increasing the number of scales, see if, here, the size of a scale is bigger. Or you can say that in the old cameras, pictures captured by old cameras, once zoom out on a computer, you can notice the blocky effects. But nowadays, due to advancement, the partitions on the CCD, basically this, you can say this kind of a partition CCD, the block, the partition is too high. What is this basically? 10 pixels, 10, you can say, block per inch. Are you getting my point?
Yes, sir.
Here, but remember the length, is thin, 254, the 254. But here, size of the blocks, pixel, partitions of the CCD is smaller, and it's 20 pixels per inch. Are you getting my point?
Yes.
Nowadays, maybe 100 pixels per inch, then even you can not consider this blocky effect. Then resolution will be increased. Otherwise, your CCD partitions will be increased. So here you can see it look like a kind of a scale in the diagonal form. But here it looks like a circular pattern.
Yes,
but in case if you will increase into 100 pixels per inch, then it will exactly look like a circle. You cannot differentiate, or you may will not notice the scale.
Yes, sir.
Like the old pictures by zooming out on the computer. This is the thing I wanted to tell you in the previous lectures. Is it clear now? So of course, if you are considering some main pixels there, so there are the adjacent pixels there, unaffected pixels there, because interpolation, for example, we are super resolution, or we want to increase the resolution with some dummy value or with some zero value. So there are many things, but we will see them at the later stage. Let's come to the screen size. Once we are talking about the image processing and computer vision, there is a little difference. but this little difference is kind of a big difference. In image processing, we are talking that how human can see. But once we are considering the computer vision, mean how machine can see. In computer, we are discussing how machine can see. Okay, here, if we are, okay, this is VGA cable, you familiar with the screen. Okay, once we are talking about this is the dimension. Okay, you can say somehow resolution kind of the, okay. And once we are SXGA, okay, this is it is also, if there is a 920 kind of thing, then it also becomes HDA. But here nowadays even we have a laptop with this kind of a resolution there. So this is also some kind of a screen, okay. So some kind of a rectangular white and okay, too much some scale nowadays very advanced 4K screen. You people should know about this.
Yep.
Because you people are studying computer vision. Furthermore, if we are talking about the bits or bit depth, what is it? With the things, okay, from this concept, you can notice very simple that depth means how your eye can observe the thing with some clarity or with some details. Depth means not that it's kind of a well or it's kind of okay. So it means how much you can observe the details. So depth is the details. Determined by the number of bits. Of course, if bits is higher, and bits are what? Bits are here. If you are comparing these two, here more bits.
Yes.
Are you getting my point?
Yes, sir.
It means bits are higher, more details will be captured, or you can say you can partition the data in a very minute manner. Okay? So, bits used to define each pixel. The greater the bit depth, the greater the number of tones. Tones mean, of course, shades.
Yes.
Tones is what? Shades basically. Grayscale or color whatsoever. As I already told you people, you are talking about the grayscale. How many shades or how many tones are there? 256. Brilliant. Similarly, if you are talking about the colors, there are 3, okay, RGB, but in Python or OpenCV it can be, okay, GBR, but usually we say RGB, okay, it does not matter if you say like the RGB or GBR, it will not, okay,
Yes, sir.
it's not a big thing. So each color, for example, red in the RGB red, there are 256 shades of red, 256 shades of green, 256 shades of blue.
Yes, sir.
Okay, that can be represent. Okay, digital images may be produced in black and white whatsoever, button, okay, gray or color, okay, but I mean the binary. Yes, please, sorry.
सर हम किसी इमेज को अगर वो प्रोसेस करते हैं या उसको किसी उसमें यूज करते हैं ना पाइथन में, तो मोस्टली सर हम उसको ग्रे स्केल में पहले कन्वर्ट करते हैं. सर ये क्यों?
Brilliant, good question. Because computational cost or complexity will be decreased. If you are talking about only grayscale, you are considering only the 256 shades. If you are considering the color, then there are 3 different shades of there are 3 patterns, 256, 256, 256 of each red, green and blue. So of course, for color image, computational cost will very high.
Yes, sir. बिल्कुल.
That's why we are transforming it into the gray, okay? I was talking about the, okay, but I mean the binary, only black and white, like this. Only black and white, no shades. So, of course, once we are talking about the button, okay, binary, then means 0 and 1, discrete language. So, bits depth a little bit more, I wanted to say here, somewhere in your textbook notion, you will see this kind of pattern, or combination 0, 0 mean fully black. 0, 1 mean the effect of 0 in a picture is higher than the white. Are you getting my point? If 0 is at first place,
Okay, sir.
on left hand side. Are you getting the theme?
Yes, sir.
Okay, because once you become a computer vision expert, then of course you will write in some kind of mathematical languages, or somewhere you will write a journal article, or you will read some books. You should know what's the meaning of this. If 1, 0 means white color in picture is higher than the black one. This is talking about the binary one. Okay?
Yes.
For example, in this one, this is, you can say, white. What you will say here? 1, 0. Why?
sir.
Because white is, okay, huge in, okay, dominant, and the black
Black
is
is less than.
okay, lesser. If somewhere you transform the image, the black transformed into white and white transformed into the black, still you can notice it. But in that case, it will
0, 1.
0, 1. It's fully 0, of course. It's 1, 1, all complete. Are you getting the situation?
Yes, sir.
Very simple. Actually, I don't need to teach you, but somehow it's important to teach. Honestly. If you are talking about the gray scale, what will happen? Basically, we are discussing the shades of gray. How many possible shades of gray? 254.
255.
Why 254? My children see, 0 represents black, 255 represent white, and remaining are, if okay, 255, 1 taken away, okay, so you will get 254. 254 for what? Kind of gray. Gray, how many gray shades? 254. 0 and 1 are the crystal clear that 0 represent black complete, and it should not be categorized as for general understanding, shades of the gray, and white, of course, it's a crystal clear white, pure white. So we have 254. So the bit that, okay, made here in form, okay, power of 2. So if the 8 bit mean, okay, it's the 256 here, then we explain the more bit detail. But before bits, okay, a color image is typically represented by a bit depth ranging from 8. This one is a very simple. 8 is, if you are talking about 2A, it's a color image, very simple color image. But if you want to consider the more variations, more shades, okay? Some students in last class was asking that, sir, is it possible to consider the more shades? Yes, possible. But of course, then computational powers, cost, okay, then the CCD also of higher quality is required.
Yes, sir.
So, can be 254, let's explain the 254, and if you go through this, okay, by reading, the bits are divided into 3 grouping, 8 for red, 8 for green, and 8 for blue. Mean that this is represent red, green, blue. Get it? So mean that 256 shades of each. Yes, please.
सर किसी इमेज पे जब हम कोई फिल्टर अप्लाई करते हैं, लाइक उसकी ना क्वालिटी मतलब बेहतर हो जाती है या वो ज़्यादा क्लियर विजिबल हो जाए, तो उसमें हम क्या करते हैं, उसमें पिक्सल ऐड करते हैं बेसिकली जो फिल्टर होता है.
We are in, okay, if we want to increase the pixel value,
Yes,
for example, if the pixel value is 200, you are adding 8 in it, it will become 208.
8.
Similarly, if somewhere the pixel value 8, after addition 8, it will become 16. So you are enhancing each pixel value. Or what you are enhancing? Light intensity
Yes, sir.
artificially.
Yes.
Okay. So once you will boost the light, okay, artificially, then overall it will pretend that, okay, enhancement or sharpening will be noticed. Okay, but somehow in this situation, on the soft details can be compromised. I will explain it a little bit later. So this is another thing. Please don't mind. So combination of those bits are used to represent other colors. Okay, here the 24-bit image offers 16.7 million shades. Okay, 8 bits represent very simple 256 shades. But this 24-bit image, why? Because you are considering this one. Are you getting it?
Yes.
So in this situation, so here the configuration tone, so basically tone is similar like shades. So 1 bit, 2 bit, 3 bit, 24 bit, until, okay, maybe some of you genius people can develop more than this, but we have systems, computing powers, which can calculate, which can, okay, compute until this one. The images we are capturing in space, okay, on Mars, okay, it is taking huge time, certain variations, so we can notice some, okay, minute details over there with the help of this one. But however, in your mobile phone, you can notice that simply this, somehow this one or this one. Okay, but maybe you people have expensive mobile phone. I could not comment on it. Okay, are you getting my point?
Yes, sir.
Do the thing.